All right, guys, we've come to our very last practice problem set, practice problems 4. We're looking at pedigrees. Remember, these show lineages or relationships in a family. So the squares represent males and the circles females. This line between them means they have mated. The line down means these are their offspring. If we see a line off an offspring, it means that is who they mated, and we see the grandchildren of the grandparents or the original folks at the top of the pedigree. If you are colored in, it means that you have the trait. You can see some pedigrees will have them half shaded in, and that's how you know they're a carrier. And some pedigrees like this one, they're blank because you have to ascertain whether or not they are, in fact, a carrier. So we're going to look at this. Remember, we have recessive and dominant. So recessive means that it can skip generations. For example, this one is in fact recessive. No one in the first generation here has the disorder, but we see it appear in the second generation. That means it must be recessive. Dominant, we'd see many circles, many more circles that are, and squares that are in fact shaded in, because it would show up in every single generation. So dominant would show up in every generation. Recessive can skip generations. Now, remember we talked about sex-linked. So that means that it might affect more males than females. From this pedigree, we don't have enough information to say definitively that it is, because we don't see more males than females in a pattern. So recessive and dominant, it can be sex-linked, or autosomal means it's not sex-linked. It can happen to anyone. So here we're looking at a trait in pedigree 1. Is it recessive? Yes. Then we are going to guess, take an educated guess at the genotypes of the father and the mother. So I'm going to guess with a good degree of certainty that the father and the mother needed to be heterozygous because I have normal individuals and I have an affected individual. Autosomal dominant, no, it can't be both. Skips generations, so it's recessive. Is this sex-linked recessive? It could be. Is it linked on the Y trait? No, because then I would see all the males having it. So we could say either way. You could say this is sex-linked recessive, yes, because it is recessive. You could also say that it is autosomal, yes. So we don't know for certainty because we don't have enough circles and squares to determine if we see more males than females. It can't be dominant, again, because not every male has it, and we see it skipping generations. All right, our second pedigree, we have the father and the mother both circled in. We have 2 females circled in and 2 males that are not. So we want to know, could this be recessive? And we know that it cannot be recessive because it doesn't skip generations. This is showing up in every generation. So could this be autosomal dominant? We see more females than males, but we don't have enough information. So yes, it could be. And most likely they are heterozygous, because we do see some individuals that would be homozygous recessive that do not possess the dominant trait. Could this be X-linked? Absolutely. We don't know enough, so it could in fact be found on the X chromosome. Could it be Y-linked? No, because not all the males have the trait. All right, our third pedigree. We have a male and a female that are not colored in. We have a male and a female that are, and 2 more that are not. Could this be recessive? Absolutely, it has to be. It has skipped a generation. Now, could this be autosomal dominant? No, we just said it's recessive. So it cannot be dominant. It can be recessive. Could this be X-linked recessive? Why not? So if we look at this, we're not seeing more males than females here. We're seeing the exact same number. So we know that that would not be X-linked. Pedigree 4. We're seeing it in each generation right here. However, we also see that it's not affecting every individual. So this could be recessive or dominant. We do not have enough information to say definitively one way or the other. If it is in fact autosomal recessive, we would see big A, the mother here, and the father, little a, because he is shaded in. So that means he has the trait. And if it was, in fact, a recessive trait, that would be what he would be. If it was autosomal dominant, we could see the father being big A. So he has that trait here, the big A, but the mom is not shaded in. So she would be little a. These children here could have gotten a little a from the mom and a little a from the heterozygous dad. And then they would have received the large A from the dad and the little a from the mom. Could this be sex-linked? Yes, it could be recessive or dominant. Again, we don't have enough information. But if it was in fact sex-linked recessive, we would see that the mom is a carrier and the dad has the trait. If it was X-linked dominant, sex-linked dominant, we could see the dad having that large A, but the mom lacks it. Again, it would not be Y-linked because we don't see it occurring in every single male. A lot of the pedigree problems that you will see like this are mainly for deduction. You have to go through and see the different possibilities and use those critical thinking skills.